Okay, exit path 7.1b come. So this one is on parallel lines and collinear points. So what are parallel lines? They have the same gradient. They have the same steepness. So because of that, they have the same gradient. Then for collinear points, what is it? Sorry, the audio is going to come into the video. So, okay. So what is collinear points means they lie on a straight line. So when 3 points lie on a straight line, okay, what is going to happen? The gradient is going to be the same also. Okay, so let's take a look at the first one. Show that the two lines are parallel to each other. Okay, so you let line 1 to be this one, y equals to negative 3 over 4x plus 8. We do some rearrangement. We let line 2 be this one, so 3x plus 4y is equals to 10. Okay, so what we do is we need to find the gradient for the first one and the second one. First one, what's the gradient? What's the gradient for the first one? Negative 3 over 4, straight away from this one over here. Okay, mx plus c. Okay, now the second one, how do we find the gradient? Rearrange and find. So we have 4y is going to be equals to negative 3x plus 10. Okay, so y is going to be equals to negative 3 over 4x plus 5 over 2. Actually 10 over 4 also doesn't matter because we are not really concerned with the simplest form as the answer. Okay, but it's a good habit lah to simplify answer. Okay, so what is the gradient over here? Second gradient negative 3 over 4. Okay, so why are they parallel? Two gradients are the same. So since m1 equals to m2 equals to negative 3 over 4, okay, the line L1 is parallel to L2. Okay, or you can say that the two lines are parallel, also can. It's just that I'm lazy, so I use symbols. Okay? Okay, number 2. Find the equation of a line, okay, passing through the point 2, 3 and parallel to the AB. One more time. Find the equation of the line passing through another point but parallel to AB. So what do we need to do is, because the line is passing through the extra point, we cannot use AB to sub in to form the equation. So what can we do instead is we have to use the gradient. We have to make use of the gradient. Make use of AB first to find the gradient. And we have to use the point over there for the equation. Okay? So for question 2A, got 2B. Okay, so for question 2A, we have AB. So the gradient of AB is going to be equals to y2 minus y1, x2 minus x1. Okay, so this one is going to be equals to 4 over 5. Okay, so what's the gradient for the other line? So the gradient for the parallel line, so the gradient of parallel line is also going to be equals to 4 over 5. Okay, so let's say if I don't know any symbol, I can just put M. You can put M2, you can also put M parallel line, also can. Okay, so then the equation of the line that we want is now y minus y1 equals to m x minus x1. So we fill in the blank like what we did earlier. Okay, the point that I'm using is going to be point 2, 3, correct? So x is 2, y is 3. Okay, and gradient m is going to be 4 over 5. Okay, so y is going to be equals to 4 over 5x. Okay, so this is 8 over 5. So 15 minus 8 plus 7 over 5. Okay, is this correct? 7 over 5?
No, I used the method wrongly. So.
Oh, okay. Okay. Alright, so for part B is a bit different. So part A, right, is talking about finding a parallel line from 2 points. Okay? Part B is different, is they give you the equation of the line and you're looking for a parallel line. But the steps are roughly the same. So for part B over here, they give the equation of the line, right? So from the first line, we have this equation. Okay, so when you rearrange the equation, you're going to get something like this. Okay, and divide by 3 so that you can see this. Okay, so based on this one, gradient 1 is going to be 2/3. Okay, and then for the parallel line, M2 is also 2/3. So you can write this or you can write something like this also can. Okay, for the parallel line, the gradient is going to be the same and we can make use of the same equation builder to build our equation. Okay, so y is equals to m. Okay, so the gradient is 2/3. Okay, what point are we looking at? We are looking at point 2, 3 also. We need to sub the point 2, 3 over here. So let me put 2, let me put a 3 here. Okay, if it's negative, you take note, yeah, need to do some readjustments. So here y will be equals to 2/3x minus 1/3. Okay? Okay, question 3. So given the following 4 points, find the value of k if AB is parallel to CD. Okay? So for this one, I'm just going to make use of 2 gradients and we can solve for k. So we got 4 points A, B, C, D. Okay? So let's do this. So given AB is parallel to CD, okay, because they are parallel, right? What can you say, what information can you use now? Because these two are parallel, so what can you say? M1 equals to M2. But in general, right, because we don't have line 1, line 2, we have AB and CD. So I'm just going to use a short trick to label my gradient. So the gradient of AB is going to be equals to the gradient of CD. Also can. You can also write like this. Okay? So what is the gradient of AB? So y2 minus y1, x2 minus x1. Gradient of CD, y2 minus y1, x2 minus x1. Okay, 2 gradients, right? So we can equate them like this. So k plus 1/4 is equals to k minus 4/3. So this becomes our Sec 1 algebra. So what should we do with this? How to solve? Cross multiply. So 4 multiply to the other side. 3 multiply to the other side. So we have 3k plus 3 equals to 4k minus 16. So here we get 19 is equals to k. Alright, or k equals to 19 if you are uncomfortable with that. Okay, last one, huh? Oh, 5/3 ah? 5/3? Okay, 5/3. Okay. Okay. All right. Number 4. Okay, show that PQR are collinear. So how do we show that 3 points are collinear? We need to show 2 things. So in order to show that something is collinear, we need to show two things. The first one, to show that two sets of lines are parallel. Now, just because two lines are parallel doesn't mean that they are collinear. Collinear means they must all lie on the same line. So in order to show that they all lie on the same line, we need to make reference to a common point. So we also need to state the common point. Okay? So because of this, how do we figure out that thing over there? Okay, so let's look for the gradient of PQ first. So gradient of PQ will be y2 minus y1, x2 minus x1. So this is 2 over 3. Let's look for the gradient of QR. Okay, same thing. Y2 minus y1, x2 minus x1. You can also look for gradient of PR if you want. Okay, so this would be 4 over 6, so 2 over 3 also. Okay, now then we are ready to do our final answer. So since the gradient of PQ is equals to gradient of QR, and because of this, PQ is parallel to QR. Okay, and the second thing that we also need to show that we need to state the common point. So based on this one, what is our common point, P, Q or R? Q is the common point. So, and because Q is a common point, okay, so we can say that the P, Q and R are collinear. Okay, means they lie on a straight line. Okay, so just like that. Okay.